think it's, ooh, my computer is frozen a little bit. Okay, I'm back, hopefully. Let's go to the slideshow. So beginning with just a little bit of a review from last week. It was a little bit of a rushed class, if I remember correctly, but we talked about this idea of error handling. So sometimes in your program, things can go wrong. Maybe you do something that's just not defined, such as dividing a number by 0. Maybe you're reading file inputs, but the file doesn't exist. What should you do then, right? And so before last week, all we did is the program crashed, right? The error gets spit out at you and you have to fix it. Last week, however, we learned how to handle these sort of exceptions using something called a try-catch block. So you have a try statement that has the code that may or may not cause an error. And then you have a series of catch statements. The catch statements will capture any errors that might happen in the try, right? And this allows the program, instead of just crashing or throwing the error, they're kind of the same thing. Instead, you're able to catch it, handle it, and then maybe move on or do something to fix that in the program itself, right? And so I have a couple of review questions. The first is, I think I actually have a typo, should be catch statements. So the first one is asking if the order of catch statements matters in a try-catch block. So we have a try, and you can have a bunch of catch statements. Does the order of them matter, right? Like if I want to catch exception A, B, C, does it matter if I go A, B, C or C, B, A or B, C, A? Does it matter how I do it? Oh, let me see a chat message. Yes, I see, Andrew, you say yes. Can you explain why you say yes? Okay, I see David typed it out probably. Yes, because some exceptions are like below other exceptions, so you have to do the ones below first. Yep. So I think the wording is almost there. The idea, like you said, is some exceptions are like bigger categories than others. So you have like more general exceptions, and then you have more specific exceptions. Yeah, thank you, Andrew. You want to do the more specific ones first, exactly. That's because it catches the exceptions in order. So you have a list of exceptions. You say, catch this, catch this, catch that, right? And so it just looks in that order. Is it this error? Is it that error? Is it this other error, right? And it just keeps going until it finds one that matches. And so if you have a general exception at the top, let's just say the most general, like any exception at the top, then immediately it's going to see that. It's like, hey, that matches. Let me go in here. Let me do what you told me to do. And then I'm going to ignore all the other catch statements, right? Which is not what you probably want. Instead, you need to do the specific ones first because those are the ones that are checked first. And if it's not the specific, then you go more general at the bottom. Right? So that's just a small thing you should pay attention to with try catch. The second question is, there's a thing that you can put optionally at the end of try catch called the finally statement. And it's run at the end. That's why it's called finally. But my question is, true or false? Does the finally statement only run if the try block finishes with no errors? Or does it do something else? Right? True or false? Let's get three answers in the chat. And we can see if we have a consensus or if people disagree. Okay, so Christopher, you said true, false. Yeah, true is the right.
One is false.
Can you repeat that? I'm sorry, I didn't hear it.
I think the first one is true and the second one is false.
Yep, thank you. Does anyone else want to give an answer for the second one? Is it true or false? So we have We have 1 for false. I think this was probably one of the last things I covered at the end of class. So I definitely went over it quickly, but the answer to this, Christopher, you're right, it's false. So the finally statement, what I said you should remember is that it's always run, right? No matter what happens, doesn't matter if there's an error or not, doesn't matter if the error was caught or not, it always runs, right? The only way it doesn't run is if your program turns off, runs out of power, right? Any other case, this will be run. So whether the try block finishes with no errors or finishes with an error, it will be run. Right? And so this is useful for like cleanup code a lot of the time. You can use this to print messages. You can use this to clean up files or scanners that you might be using, so on, right? It's just like a guarantee that whatever you put in the finally statement, it's just always going to be run. So anything that you want to be run, whether there's an error or not, you should put it there. So going over the homework, I saw I had some submissions and it was based off the previous weeks. So let me just pull that up really quickly. So the homework 2 weeks ago was writing a simple program. Let me just run it actually. It will ask the user for an input for like a file. And so I want to read first.txt and it reads it, right? Hello, this is file number 1. But if I run it and I type in a file that doesn't exist, for example, a.txt, then I get error messages, right? Because at this point, we didn't know how to handle errors, right? All we did is throw this file not found exception, right? If it happened, we just throw it. And then if it happens, we just throw it. And then eventually we can't throw it anymore, it just crashes, right? So the homework for last week was to modify this program or the one that you had so that we don't do this throwing of errors. Instead, we have a try catch to handle it ourselves, right? And so the solution to this was actually pretty simple, very few lines of code. The thing that you had to know is what is causing the error, or at least what can cause the error. And so what can cause the error is actually this line of code right here. You can actually see it in the error message itself. If we take a look, it says exception in thread, and then it tells you where it happened. And if we go all the way to the bottom, you can see it happened at Java 2 class 4 homework .main, and oops, I meant right, I think right here, Java : 17. And so that tells you it's line 17. And if we look at line 17, it's this line. You'll see that also says Java 11 here. That's because 11 is what's calling this method. And so it's kind of like a chain reaction. This causes the error. This causes the error because of this, line 17. Line 17 causes an error because of scanner line 639, whatever that is, right? Wherever it exists. Right? We didn't write that ourselves. That's what someone else did. But anyways, this is the line of code that's causing the error. And so this is what we need inside the try catch, at least. And so the simplest thing to do actually is just to put try around our whole code, right? There's not really anything wrong putting more in the try statement, right? So we put everything in a try, but we have a try, so we need a catch, right? If we look at the red underline, it's actually telling us right now, syntax error, insert a finally to complete try statement. Basically it's saying you have a try, you need to put something to finish it off. You can't just have a try by itself. And so it's saying to put a finally, but we can also put a catch, and which is what we want. Catch. And then the thing that maybe I didn't spend too much time on is what's inside the parentheses. And I just said, oh, put the error type file not found exception. and then you can put code inside. And so this is maybe the most confusing thing about try-catch, just the syntax, like why do we do this stuff here? The way I like to think of it is this is kind of like your parameter list for your method, right? File not found exception E, this is similar to like string file name. This is basically the data type. This file not found exception is actually a type, just like int, just like Boolean, just like string. This is just a type. And then E is like a variable. And so actually inside of here, you can do stuff with this exception object. Right? This is a file not found exception object. And so you can do things like print stack trace, which is basically this message right here. But you don't have to use this thing. You can print your own message like system.out.println can't find file. Right? But that's just what the syntax is. You need to put the type of exception that you're catching, as well as like a name for it, a variable name for it that you can use inside the catch. And so with this is basically done. You'll notice I have an error here, and you may or may not have run into this, but this is saying basically it doesn't know what SC is, right? And the reason for this, why it doesn't know what SC is anymore, is because you were creating SC inside the try block. And if you notice, the try block is inside these curly braces. Something actually closes right there. So something I didn't mention too carefully before is when you have these curly braces, any variables that you create inside of them only exist inside the braces, right? Just like if you make a variable inside a method, the variable doesn't exist in the main method, for example, right? Like if I say int x equals 5, x does not exist here, right? Because it's a different set of curly braces. And so that's the exact same thing that's going on here. If you look, our code, we're creating the scanner SC inside of the try, which is inside of these curly braces. So now when we have sc.close outside of it, it doesn't know what SC is, because once you've left this section of code, it kind of forgets about everything that was inside of it. So it forgets about the scanner SC that you just created. And so it doesn't know what you're trying to do here. And so the solution here, one solution at least, is just to move it inside the try statement, right? Because now when it's inside the try statement, it has access to this scanner variable that you created, right? Because it's still inside the same block of code. Right. With that, the errors here are gone. One thing though is you no longer need these throws statements, right? If you remember, we put these because it was an automatic suggestion from Eclipse, basically saying, hey, you either have to try catch or you have to throw the exception. And so now we have a try catch, we don't need to throw it anymore. We can get rid of this, right? We can get rid of it in both methods. And now if I run the program, you'll notice that if I give it like a valid or a good input, it does exactly the same thing, right? I can say first.txt, and it does the same thing, just works like before. But now it's better because now I can say, I want to read fifth.txt, and it says it can't find it, but it doesn't crash, right? It very nicely prints a message and then just stops itself. You could modify this further by, instead of just stopping, right now the program finished, you could say, if it can't find the file, it just ask you again. And you just do that with a loop, probably a while loop. So inside of here, you try this, and then if it doesn't work, you just repeat it. Yeah. Does anyone have questions about this homework? Again, it really is not that much in terms of the code. It's just a try and then a catch right here. That's just what we added to the previous week's homework. We could put a finally at the end, but for this one, not necessary. And the finally statement is not required. Like it's an optional thing. It's an extra feature to the try catch. All right. So I'll say this before moving on. Try catch is, I'd say, very useful in the sense that, well, it's very important, right? So programs do have errors in them, like exceptions. They come up even if you write the program perfectly, right? Don't think of try catch as, oh, if I just am more careful in my programming, I never have to deal with try catch. That's not how it works, right? A lot of times when you're dealing with user input, you don't have control over what other people are doing, right? You might want exceptions to show up when things in your program end up in a state that you weren't expecting, and you want some sort of like notification of it. And so it's very important to know how to handle these things. I will say though, for this class, we won't see any like required places where you're going to need to use try catch. So take it how you will. But I'd say it is good to understand it so you can use it moving forward. A lot of times, personally at least, I just write the code, and if it tells me I need to try catch, I just add a try catch. Or I run the code and I see this error happens, I will then put a try catch later on, right? It's not always something I think of first. So I don't see any questions at this point. So I want to move on because today's class is going to be a little bit special in that it's kind of a new chapter to Java 2. And so the next couple of classes, next couple of weeks, are all going to shift their focus a little bit onto a different topic. And I'm just going to introduce that today with some basics. And hopefully, by the end of today, some of the things that up to this point, I've just told you, oh, just do it this way. I'll explain later. Hopefully some of that will be more clear and I'll actually have explained some of it, including some of this like public static thing. Yeah. Let me go back to the slides. And if we go flip to the next page, you'll see today's class is about classes, kind of meta. But Java is what's known as an object-oriented programming language, sometimes abbreviated as OOP. And object-oriented, if we break that down, it just orientated in this case means it's like focused, right? It's focused on objects. It's a program language focused on objects, based on objects. Objects are the most important thing to this language. And so you might have heard, you've definitely heard me talk about objects before. And so what are objects? Well, pretty much everything in Java is an object, right? So I have 3 different examples. When you say int x equals 5, x is an object. When you say string y equals hello, y is an object. When you say scanner in equals a new scanner, that's an object, right? Basically everything you work with in Java is an object, right? If we look back to this program, like this file is an object, the scanner is an object, the line is an object, so on, so on. Like this is even an object. Basically everything is an object. And so how do classes fit in? Like everything's an object, but I haven't talked about classes yet. And so how classes fit in is they're kind of like a blueprint that tells you how to make these objects. So classes represent, in general, properties and methods that are all common to one type. And actually classes are very closely interlocked with each other. So when I say this is a string object, the type of the object is a string. there's also a string class, right? It's because there's a string class that there's a string type. And yeah, I think my computer is struggling a little bit. I notice sometimes it freezes and I think it cuts out, but what I've just been talking, thank you, Andrew and Marilyn. Yeah, hopefully it stays good for the remainder of class. But classes are a blueprint. They basically describe what's similar between all these different objects, right? In the sense that like you can have different strings, right? You can have one string that says hello. You can have another string that says bye. Those are different strings, but all strings share some things in common. For example, they have a length, right? You can convert them to uppercase. You can convert them to lowercase. That's all things that the class defines. And so in general, again, classes are a blueprint. They contain properties and methods. An object is an instance of that class, right? So I'm throwing around all these terms. And so I think it's a little bit helpful to think of like an example. And so this is a really dumb example I've come up with. I'm comparing classes and objects in the real world sense with cars. And so you can think of the class as like the definition of what a car is. And so this is Google, a four-wheeled road vehicle that is powered by an engine and is able to carry a small number of people, right? It basically describes what a car is. And it's more of like an idea, right? It's not a specific car. It's just what are cars in general? What do all cars share in common, right? What do all cars have? What do all cars do? That's what a class is. An object is a specific car. For example, I have a Tesla, a Ferrari, and a Volkswagen Beetle, right? They're different types of cars. Those are different objects, right? You can see how they're kind of related to each other. You have to have the class to create the objects, but they're separate things, right? And so for now, we've already been working with these objects a lot, right? So far, that's everything we've done is working with these objects. But today we're going to learn more about these classes, how to write your own, and just really understanding how they work. So continuing this example for now, I want to stress this idea of properties and methods. And so, let me go back to this slide really quick. Properties, they're just variables, right? The term that I'm actually going to use more often is a field. So properties and fields, they mean the same thing. Classes have fields. Fields are just variables. That's very simply, that's all they are. They're just a variable. It could be an int, it could be a string, it could be a Boolean, it could be an int array. It doesn't really matter. It's just a variable. And a way to think about it is it's like what a class has. Methods, on the other hand, we've seen this in Java too. That's kind of what we learned in the previous first couple of weeks. It's what the class can do. It's what the class does. And so going back to this car example, I want to talk about what properties, fields, and methods that this car class might have if we were to make this in Java, for example. And so first, the properties, what the class has. So a car has a color, and this might be a string. We don't really know how to store colors yet, but you could store this as a string, right? Maybe it's a blue car, maybe it's a black car, whatever. It could have a weight associated with it, right? And this might be stored as a double because you want decimal values. This is where I want some of you guys to help me out. What are some more properties or fields that you can think of that a car class might have? Like another way to think about it is what would you use to describe a car? Like what kind of features do cars have? Alan says speed as a double. I think that's a great idea. So you can store like maybe the current speed, you could store the top speed, two different properties that you could have. Andrew says the brand. So I think you already know, but if we're having the brand, I think that's a good idea again. How would we store that? What kind of data type would we use that we know in Java to store a brand? String, yeah, great. Yeah, we can store the brand like a Honda or a BMW or Tesla or whatever, right? Other examples might be like number of passengers or like how much gas is in the tank, right? These would be integers for a number of passengers, hopefully, and probably a double for like the gas tank. So on. You can think of so many different properties, right? On the other hand, the methods, what the class can do, a car can park, a car can brake, a car can drive, a car can turn left, a car can turn right, right? A car can accelerate, decelerate, right? Those might be methods that you would put in the car class, right? And so this is still kind of a more like not a concrete example that we're gonna write in Java, but this is hopefully helpful to understand what a class is. Again, I want to stress this a lot. The difference between classes and objects, you have to create the class first, and then you use the class to make the objects. The class is just the definition, it's the blueprint. Inside the blueprint, you have properties, which are just variables that store information, and you have methods, which describe what an object of this class can do, or what this class can do in general. Okay. So now I want to look more at like a real programming example. And so I'm gonna open up my Eclipse again, and hopefully you already have it open, or if you can get your Eclipse open as well. And so the first thing I wanna do, before I really touch anything, you may or may not remember, but we've seen classes before. Everything we've written is actually a class. When we're doing the homeworks or the examples that I've been going over, everything is inside of a thing called a class, right? I've told you when you want to write a new Java file, what do you create? You create a new class, right? And so let's just make kind of a dumb example of the car class that we just talked about. I'm not going to have all the properties. I'm not going to even have all the methods, but just to demonstrate how this would work, right? And so let me create a new class to start off with. So again, new class, right? Here, the name of it, I'm going to name it car. And one note here is that in general, classes begin with a capital letter, right? This is just the standard. This is something that you should get into the habit of doing. And it's actually pretty useful a lot of times. You'll notice this is different than most things that we've done so far, right? Variables tend to start with lowercase letters. Classes start with uppercase. And so another thing here is I'm not going to select this public static void main thing at the bottom, the method stubs. If you've gone ahead, already selected it, no problem. You can just delete it, what's automatically generated. But we're not going to use that for this class. So I have just a blank file at this point, basically. And all I have is public class car. And this is actually all you need to define a class, right? You have this public thing. For now, that's still just going to be a magic word. You can kind of guess what this means, but this is a public class. And then we just literally say class. That's the Java keyword. It's just the special thing that you say when you're creating a class. So it's always going to be there. And then you have your class name. In this case, it's just car. And then there are other things that you can put here, but for now, we're not going to get to it. We're just going to do a very simple class to start off with. But what goes inside this class? Well, we just said you have properties and you have methods. So let's write a couple, right? So first, let me do my properties. So Marilyn asks, what should we name this file? The name of this file has to be the same as the class name, right? So in my case, I'm making the car class. If you're following along, you should probably also just call it car with a capital C. If you want to do something else, feel free. But yeah, the name of the file should be the same as the name of the class. It's required to be that way. If you don't have it matching up like that, it's actually going to cause problems. It's going to tell you, I can't let you do that. But let me add a comment right here. So this is going to be our properties or fields, right? And so what are some of the properties that we talked about? Well, I'm just going to use the ones from the chat. So we probably want the speed as a double. So double speed. Oops. Double speed. And for now, we don't have a speed. So I'm just gonna leave it like that. And then we can have a string brand, right? Again, for now, we don't know the speed, we don't know the brand yet. So I'm creating the variables and saying they're going to have some value, but for now, I don't know what they are. I'm just creating the space for it. I'm telling you there will be something here, right? So I added the properties. Now I want to add some of the methods, right? So let me just add the comment methods. And so let's just add like a break method, for example. And so just like any other, well, this is where we're going to see something different. Here, I'm going to say it's a public method. It's not going to be static, and I'll explain why later on. The return type is void because I don't need to return anything. And the name of this is going to be break. Oh, break. And there's no inputs. And I have the body of the method. And to break, I'm just going to say the speed equals 0, right? Because that kind of makes sense, right? When you're braking, your speed stops. And I can say, have another method, maybe drive. And what drive does is set the speed to, I don't know, like 60 miles per hour, something like that. So this, at this point, is a class. It's not a very interesting class. All it has is a speed and brand property, and it has two methods, braking and driving. Right. At this point, I want to introduce another method here, and it's a very, very special method. This method is called the constructor, and based on the name, you might guess, this is how someone knows how to make a car, right? We define the class, we define the blueprint, but we also need to define how to make a car, right? And so that's what the constructor is for. It's just a method, but it's a very special method. So I'm going to put it in the method section, and I'm actually going to put it at the top. And I'm going to make a note, this is the constructor. Just like the other methods here, I need to give it public. And because this constructor is a special method, it looks a little bit different than the ones that you see here. You don't really specify a return type, and the name of it has to be the name of the class. So I have to call it car. Right. Again, there's no return type. I don't have even void here. And the name of it is set. It's car because the class is car. If I change this to like truck, then I'd have to change this to truck, right? But for now it's car, so this is called car. Andrew, good question. I will hopefully get to that today's class. If not, definitely next week's class. The difference between static and non-static is actually a little bit confusing. We have to get through this first. It's related to classes, right? Yeah. So here, again, the method, going back to the constructor, the parameter list. What do we need to construct a car? Like what kind of inputs do we need so that we can create a car in the first place? Well, based on our fields, we have a speed and brand. We probably don't need to take in a speed to make the car because we can just start the speed off at 0. So we don't need to take in a speed, but we probably do want to take in the brand of the car because we have no other way of getting that. So I'm going to say that this constructor takes in a string, and I'm going to call it B to be less confusing. And that's all it takes in, right? And then what does it do inside? Well, typically what a constructor does is gives values to your fields. In this case, the speed and brand. So like I said, speed probably can just be 0 to start off with, right? Our cars are always sitting still when we're creating them. And then my brand is just going to be equal to whatever string I am passed in, right? It's the parameter to your function. And that's it, right? That's the constructor. To recap, this is the special method that is used to create cars in this case. The method signature looks a little bit different. The way I like to think of it is that even though it looks like there's no return type, I like to think of it almost like that this method returns a car. And so the return type is car and the name is car. And so since it's the same thing, we don't say it twice, we just say car once. It's not really like that, but I like to think of it that way, right? Because really that's what it's doing. The constructor creates a car. So the return type is kind of like a car. And then it takes in a string, and then inside of the method, it just sets these properties. And then we have some other methods here, break and drive, that just manipulate the speed a little bit. And so we created this class, and that's all good. That's interesting. I can hit play, and it's actually not really going to do anything, or actually, it's still trying to run the previous thing. I can try to do run, or yeah, so you can try to run this. It's a little bit complicated, but it's just going to say it doesn't know what to run because it doesn't have a main method, right? If you notice, this defines things. It defines the car, defines fields, it defines methods, but doesn't actually do anything by itself. All it is a definition, right? And so we need to make something else to take advantage of this class that we just wrote. And so for the first time, we're going to have a program that uses 2 files, 2 classes. And so I'm going to create another class. And this class I'm going to call like the runner class, because this is what I'm going to use to run everything. And in this class, we're going to go back to taking this main method thing, because since this is running everything, it needs the main method, because that's what gets executed when you hit the play button, right? And so I created a second class, my runner class. And in here, in the main method, and here's where I can create my car, right? And so how do I create a car? Well, I use the constructor right here, right? And so just as an example, this is like scanner sc equals new scanner system. This is just an example. This is like creating a scanner. And what we're going to write looks very similar, right? The first thing is we're not creating a scanner, we're creating a car. right? So I'm going to say car. The name of it, I'm just going to call it C for short. And then equals. Here, we're not creating a new scanner. We're creating a new car. So we say new car. And then what goes inside the parentheses is defined by this constructor. So our constructor says it takes in a string B. And so we need to give it a string. So I'm going to make a Tesla. I don't know, like that. And you'll notice we're good here, right? So I'm going to delete the scanner line. And notice this is what it looks like now. Car C equals new car Tesla. Right. This line creates a car object, right? Again, this is the car class. This is like the definition. This is the blueprint. This is using the blueprint, using the definition to create an object, a specific car. And a term for this is an instance. It's a car object instance. It's a specific car, right? I can create another car, right? I can say car C2 equals new car. And then this one, I'm going to make a Toyota, for example, right? Now I have two cars. Right? I can create a third car. It's Volkswagen. Lazy to type it all out, but there, right? So I created a Tesla, I created a Toyota, and I created a Volkswagen, VW. We have three cars, right? I can create as many as you want, right? And yeah, oops. I was right, and then I thought I was wrong, and then now I've corrected it back to what it should be. Oh, wait, no. Oh my God. Okay, it is VW, but I'm just gonna make it BMW. My spelling is off. I can't think. I'm just gonna avoid it. I know BMW is the correct thing now. So I created three different cars. Really quickly, let's just call this C1. And now if I run this, it will run, but it doesn't really do anything interesting, right? Now notice it runs and there's no output, right? Because this program, all it does is creates three cars and then it finishes, right? So there is no output. There's nothing for us to see what's going on. What we can do now is create some output. And what I want to teach you now is how to access some of these things, your fields and your methods. So really quickly, I'm going to actually put public to be safe. And so these properties typically have a visibility, is what we call it, associated with it. So I'm going to add public in front of these. And I'm going to show you what's the difference between public and private right now. And so here is a public double speed. And actually, I can show it right now. This is a private string brand, right? And so based on these properties, I can access them. So using the first car, C1, I can access the speed, right? So I can say the speed is a double, I believe, right? Yeah, it's a double. So I can say like double D equals C1 dot speed. And if you notice, when I hit the dot is the special operator that allows us to access the properties and the methods. And when I hit dot, Eclipse is actually super smart. It already knows I created this car.java file. It already knows what's inside of there. And it already knows that there's a field called speed. And notice it says speed : double in the car class. Like it knows it's there, right? Even though this is something that I wrote, it's custom. No one else has the same thing unless you're just following along. Like this is something I just wrote today and Eclipse knows what's going on. That's why the ID is really nice. But we can just say C1.speed, and this accesses the field of the car object, right? And I can print it out. System.out.println d. Right. And now if I run this, looks like my windows shifted around, but you can see it prints out 0, which is kind of what we expected, because when we created our car, it starts off with speed equals 0. And so right now I can say like C1 dot drive was the method, right? And you notice it already knows it exists. C1 dot drive. And now I can print out the speed again, right? Let me, if my mouse will cooperate, I can say C1 dot speed. And if I hit run, you'll notice now it prints out 60. Right? Because that's what we said drive does. It makes the speed 60. And then I can break and then print out the speed again. And you'll notice it should go back to 0. And you notice that's what it does. Starts off at 0, I drive, go up to 60, and then I go break, go back to 0. Right? This is how you access the properties, the fields, as well as the methods, right? Using this dot, the period. And so if we've seen before, actually like in system.out.println, that's kind of what you're actually doing here. System is a class, out is another class, and then println is a method of that class, essentially. And so here, we have our C1 object, and we use it to access the method, and we use it to access the properties. Right? Notice at this point, I've only been accessing the speed. Let's see what happens when I try to access the brand of the car. Right? What if I try to do system.out.println C1.brand? Right. Even before I hit run, it tells me there's an error. And if we hover over the red line, it says the field car.brand is not visible. Right? This is exactly what I was talking about, the difference between public and private. It's based on the visibility. Who has access to this thing? Right? And so when we say that the speed is public, that means anyone, anywhere can access this field. Anyone can look at it, and anyone can actually modify it if you want. So here, that's why we can do C1.speed here, right? We're in a separate class. This is a different class than the car class. Like we're somewhere else. You can imagine this could even be like really distant from each other in terms of where the files are located, right? But we can still access it directly. On the other hand, the brand is private. Private means only inside this class, only inside these curly braces can you access this field. Anywhere else, it's not allowed, right? Strictly not allowed. And so that's why when we try to do C1.brand, there's a red underline. Like Eclipse is smart. It says it's private. You don't have access. You can't look at it. So I'm not going to let you do C1.brand. It's just not allowed. Right? The same thing applies to these methods. Right? I can make the break method private. And that would be a really evil thing to do, because if I hit save and go back to my runner file, you'll notice now I'm not allowed to break, right? That's because break is a private method now, right? And I'm not allowed to do break in this runner class because I don't have access. It's private, right? And so that's kind of what it means to be public versus private. Public means anyone can access it. Private means only you can access it. Like only, in this case, the car class can access it. Right? And so that's why we can't do break if it's a private method. So let me go back to public so that if I hit save, now it goes back to working. Right. Notice again, let let's do this. In the time left, I want to go over the difference between, it might be cutting out. Although I think I'm back now. Let's go over the static versus non-static thing in the last 10 minutes of today. First of all, note that here, we never say static anywhere. And so the first thing I want to talk about is the definition, what it means to be not static. It means to be instance. So instance and static are opposites. Right? So I'm going to type that in chat. Static and instance. And so really quickly, the difference between static and instance, the best way I think of it, is that static means that there's one copy for the whole class. Instance, on the other hand, means that there's a different one for each object instance, right? So the speed and the brand we're saying are both instance because they're not static, right? If it's not static, it's instance. If it's static, it's not instance, right? It's one or the other. You can't be both. So here, these are instance properties, instance fields. And that makes sense because each car should have their own brand. Each car should have their own speed. But let's just say really quickly that we made a mistake. And let's just say we made the brand static, like private static string brand. Right? And so now there's some warnings, but we make this static. We go back here, and actually, I'm also going to make this public so we can access it. If we go back here now and delete what I have, I'm just going to print the brands of our different cars. System.out.println c1.brand, and then I'm going to do system.out.println c2.brand, system.out.println c3.brand. And notice here I have some underlining, but it's not a problem, right? So it's a warning. This is not an error. So if you see this yellow underline, oftentimes it means that you're doing something you're not supposed to be doing. So you should be paying attention to this, at least with the programs that we're going to be writing in Java 2. But you can hit run and it will run it for you. But if we hit run now, you'll notice something a little bit weird. You'll notice all of the brands, C1, C2, C3, are all BMWs, which should be a little bit weird, right? Because we said the first one's a Toyota, the first one's a Tesla, the second one's a Toyota, and only the third one's a BMW. So why are all the cars now BMWs? Right? That's because we made it static. When we make it static, it means that there's only one copy now, right? There's only one copy. So when we create a car, we set the brand to that, whatever we pass in. I like your comments, Stefan and David. I do like BMWs, but unfortunately, that's not the answer in this case. I like it. What's going on here actually is that when we're creating the different cars, we're setting brand to whatever we are passed in. So the first time Tesla is passed in, then Toyota, then BMW, whatever. And so each time this brand variable is updating. But the difference now is the brand variable, there's only one shared one for all the cars. So it's actually just getting overwritten every time we're creating a new car. And so this is like what I call a bug, right? This probably is not what you want it to happen. And this thing of making a property static when I should have made it not static is actually a problem that I ran into when I was learning Java the first time. So it's always interesting teaching it because static is honestly just a really confusing thing. I didn't really understand what was going on. So I just put static in front of everything, right? Because I was so used to doing like public static, public static, public static, that just made my properties public static as well. And if you do that, you have to be like conscious of what that means. You should not just put public static in front of everything now. For these properties, if you want each car to have their own version, you need to make it not static. Right? If you want one version that all the cars share, then you can make it static, right? And you should. Another way to think of what static means, static just refers to classes. So like the idea of classes and what static means, they're connected, right? You can't have one without the other. And that's what it means when a method is static. So we talked about what it means for a field to be static, one copy for all the cars. For a method to be static, it means that you don't need an instance of the object to do the method anymore. And so I'm going to go back to making this static, or I'm going to make the speed static now. So now all the cars drive together. If you drive one, all the other ones drive, which is really weird and probably not what you want, but that's how it works now. And I'm going to make the drive method static. Right? That's what we've seen before, public static drive, whatever. Right? And so if we go back here now, well, first of all, notice brand is no longer static. So now the brand is what we were expecting, Toyota, Tesla, Toyota, BMW. But now let's check out the speed thing. Oh. So the speeds are static, so they all have the same shared speed. But let's check out this drive method. Before, if you remember, we were doing something like c1.drive, right? And so technically, you can still do this. You don't need the prints because it doesn't print out anything. You can still do c1.drive, but now we get a warning. We get a warning because this is no longer how you're supposed to use the drive method. It used to be instance method, right? Without static, it's an instance method. An instance method means you use an instance of the class to use the method. So here, C1 is an instance of the class. We use that to drive, right? C1 drives, C2 drives, C3 drives, right? They each drive. But now drive is a static method. It's no longer instance. You no longer use an instance of the class to drive. You can use the class itself, or that's how you're supposed to now. So now you do like car.drive. You do the class name.drive, right? Before we had an instance, right? Now we have a class. And so that's what I mean by static refers to class, right? If a method is static, then you're using the class to do it. If a method is an instance method, you're using an instance to do the method, right? So again, let's go back here. Break is still instance, right? It's not static, so it's instance. Break, we still do like c1.break. Drive on the other hand is static. So instead of an instance, instead of a specific car, you would put the class name dot the method. And this is also still like one copy, kind of like there's now one drive method that's shared among all the cars, right? And so when you do drive, it means it does it for all the cars essentially. Kind of think of it that way. Yeah. I will continue talking about this static versus instance thing next week as well. Just wanted to introduce it because I know for the longest time I said always do public static, public static, public static. Hopefully the public private thing is a little bit clearer now. And hopefully the public static, static versus non-static is starting to make a little bit of sense. But that's all the time we have for this week. I want to end it off with going over the homework. And the homework for this week is a little bit different in the sense that it's more open-ended. So I don't have like a specific task for you. I just have some guidelines. And so the homework for this week is to create your own class. All right, so today we went over making like the car class. I want you to come up with your own class for your whatever you want. And so like very common examples would be like an animal. So you could make like a dog class. What are some properties a dog might have? It might have a weight, it might have a breed, it might have a color, it might have a size, whatever. It might have a bark method, it might have a walk method, whatever. You could have a student class that has maybe a name, an age, and a grade. And it can like eat lunch, it can go to class, it can leave school, whatever, right? It's up to you. The only requirements that I have is that it should have at least 3 different fields, and it should have a constructor that you write. Just like how we wrote one for a car, you should write a constructor for your class, and it should have at least 2 methods. What these do is up to you. You can have the methods just print statements, like you could just have a print hi instead of one of your methods. It really is up to you. I just want you to practice creating your own class. And so beyond just creating the class, writing the definition, I want you to also have another file where you're creating instances of that class. So what I mean is like what I did today. I not only defined the car class here, but I also had another file where I'm like using it, where I create some cars and then I use some of the methods that I wrote. So I want you to do the same thing. Essentially, the homework is just what we did in class, but on your own. This is a little bit more open-ended. So if you are stuck at the beginning, don't know what to do, don't know what's a good idea, I'm happy to help, especially with that for this week. But any stage, if you're confused, running into issues, just leave a comment, reach out to me, and I'll answer as soon as possible. That's all I have though for this week. Thank you for sticking with me. If you have any questions, I'll be sticking around afterwards. If not, have a great week and I'll see you next Thursday. You're welcome, Devin.
Bye. See you next week.
Bye, Stephen. Bye, Christopher. Andrew, do you have, oh, you too, Andrew.